Now that we have some of the basics down with coding and our analog input of the potentiometer, let me show you a couple of other cool things you can do with it. So what if we wanted to change our LED to blink at a different rate based on where the potentiometer was? It's actually pretty easy to do, and we're going to use the same wiring setup that we used in the previous video. So we've got our setup is going to be the same. Our A1 analog in is going to be our input, which goes to the middle controller of the potentiometer, and then our digital out one is turning on and off the LED. Okay, so first thing we're going to do is we're just going to turn on the LED. Let me use the digital right function for that, and we're going to pin number 1, and let's go on high because we have to turn it on and do something with it. Okay, but then we're going to use that analog read, which converts our analog signal into a number from 1 to 1024 as our delay in milliseconds. That actually works really well because, about 1,000 milliseconds is a good amount of time you can see. Lower end on the milliseconds is going to be a much faster blink. So to do that, we're going to delay. And what are we going to delay? Well, we're going to delay whatever our analog read signal is. So we use that same analog read command. We need to tell it what we're reading. Remember, we're reading A1 because that's our input. And now you see we've read that in that set of parentheses, so we need to close that set of parentheses, but then we also need to close this other set of parentheses. So we end up having 2 in a row, and then we place our semicolon. Okay. After we delay that, we're going to turn off the LED, so we're going to digital right. I spelled that digital right. Number 1 to a low power state. Close our parentheses, semicolon, and then we're going to delay the same thing. You could actually just copy that line. Sometimes it's fun to type things twice. A1, double parenthesis, close, and close our bracket. So again, we've set our initial integer to 0 for our sensor value, so we've kind of recalibrated that. We've told it what we're using as our input and our output, and then we're turning it on, delaying whatever position the potentiometer is, turning it off and delaying again, and then it'll loop back up on and over again. So let's turn our potentiometer, oh my goodness. I'll start our simulation. We're going to turn our potentiometer to our lowest setting, and it looks like it's constantly on. Let's move to the 3 o'clock. We can see it's blinking fast. Let's bring that up to 12 o'clock. Blinking slower. If we go all the way, that'll be at our 1024, a slow blink. So pretty simple code, but does a really cool function with our potentiometer on there. Let's do one other thing with our potentiometer in this video. So let's do multiple LEDs and have the position of the potentiometer tell us what's going to happen with those. Okay, so we've already got a red LED. Let's throw in 2 more and make kind of a little stoplight. We're going to make this a yellow. And let's bring in 1 more and make that green. And we're going to bring in our resistors for the second half of our loop here. Okay, and we're actually going to use multiple ports now. Let's leave, actually we're going to bring number 1, let's bring that over to our green anode. Make 2 our yellow, and make 3 our red. Okay, so we're making kind of a little stoplight here. So imagine that maybe you had this potentiometer was controlling something, and like the volume of something. Maybe it was your volume knob on your headphones, and you wanted to show somebody that, well, when the volume is low, you're in the green state. That's really good. It's not going to damage your hearing. As you move it up to the middle state, that's a little bit louder. That might damage your hearing over time. And if you make it really, really loud, then that's kind of red. That's going to be, damaging your hearing. Can you tell I'm a musician? This is the stuff I think about. Okay, so There's going to be a bunch of code for this, and we have to alter some things because we're using multiple pins now. So let's set that up. Okay, we still have our sensor value calibrated to 0 to begin with. Our A1, our analog in 1, is going to still be our input. Okay, pin 1 is going to be an output. Pin 2 is going to be an output. And pin 3 is going to be an output. Okay, so we have those 3 outputs set. Okay, and we've told the Arduino what we're using. Okay, I'm going to further clarify this with a comment by adding 2 slashes to remind me that pin number 1 is going to be at my green LED. Pin number, whoops, our pin 2 is going to be our yellow, and pin 3 is going to be our red. That just kind of, these comments don't actually affect the code, they just help remind me what I'm doing. Okay, so we go down to our loop now, and we need to read the value of our sensor. So we're going to analog read A1. Okay, and then we're going to do some things with that. Okay, so let's say we've got 3 things here, and let's say if it's below half, then we're going to be in the green. So if our sensor value is less than 512, actually let's make it less than or equal to 512. Okay, then we're going to now we have to actually tell it to do 3 separate things here. Okay, we're going to tell it to write pin number 1 high, close parenthesis, and that. We're going to write 2 to be in a low power state, which is our yellow, and 3 to be low power state as well. Okay, so there's our first statement, and we're done on that. We have to close out our bracket. We can do that here, or if you want to be super clear, we'll put it there. It's nice because it lines up. Okay, let's do our second if statement, and actually we're just gonna, let's just copy and paste this because this will save some time. You don't have to listen to the clicking as much. Okay, so if the sensor value is, we're going to say greater than 512, and to do and, we do a space, 2 ampersands, and we have to say the same thing again. And if the sensor value is less than, let's just say 1,000, okay, then we're going to digital write the green pin to be low. We're going to make yellow high, and we're going to leave red low. Okay, so now we've got our low setting is going to be green, kind of the halfway to high is going to be yellow. Now let's write code for the red LED. Okay, if our sensor value is greater than or equal to, I think we can do this, oops, equal to 1,000. And actually we don't need this last part, so that's just going to be from 1,000 to 1024. Then we're going to write green low, we're going to write 2, which is yellow low, and we're going to write red to be high. Okay, let's just double check our math here. Okay, we've got our integer set up, we've got our void set up here with our 3 outputs and our input. We've got our opening bracket and our closing bracket for the entire loop. We've got our, we're reading our sensor. We've got our first if statement, and those brackets are closed. Our second if statement, those brackets are closed. And our third statement, both of those brackets are closed. Hopefully this is correct. Let's start the simulation and see what happens. Okay, so we've got our potentiometer in this low section where our green LED is lit up. Once we get to half, we should switch over to yellow, and green is turning off. So now we're in the yellow section, and once we get all the way up here to the very high section, now we're in the red. Okay, so again, just those simple if statements where it's reading the position of the potentiometer to light up the different LEDs. And here's one last look at the code.